let me give you some scenarios. Let's think about what this means. So if I say x to the, let's say I say 3 over 5. I'm going to have you write that as a radical in a second. Let's do another one. Let's do x, and then I'm going to do another one, x raised to some power, x raised to some power. And then let's do the numerators and the denominators, and we'll see where that comes, what all this stuff means. So this one's going to be 1. This one's going to be 5. This one is going to be 3. And then for my denominators, I'm going to have 1 over 8. 5 over 3, and then 3 over 2. Now, what I want you to know is that the shortcut rule for this is that if I have a raised to the m over n, then that's the same as the n root of a to the m. That's the rule. So I can convert a rational exponent. This is a rational exponent. I can convert that to a radical by knowing that the base is x. Okay. In fact, all of these, they're going to have a base of x. But then we have to do the root. This is the 5th root. This is the 8th root. This is the 3rd root, and this one is a square root. The numerator of the rational power is going to be the power of the base. So this will be to the 3rd power, this will be to the 1st power, this will be to the 5th power, and this will be to the 3rd power. So that's the first thing I want you to know. So I'm going to leave that up there so you can finish writing it down. But those two things equal the same thing. If I take the 3rd root of x to the 5th power, that's the same as, in other words, if I take this, that's the same as this. If I take x to the 3/5 power, that's the same as taking the 5th root of x cubed. X to the 1/8 is the same as the 8th root of x. X to the 3 over 2 is the same as the square root of x cubed. Okay? And all of these are an application of this property here.